Back again. Now I'm going to look at 2017 10A because this is quite similar to the ones that we were looking at earlier in the week. So 10A says a particle starts from rest and moves in a straight line with acceleration 25 minus 10v. So that's going to be my starting equation, 25 minus 10v. V is the speed of the particle. After time t, you've got to find v in terms of t. And you're given a little equation. It tells you that the integral of dx over a plus bx is equal to 1 over b times the ln of a plus bx plus c for your constant of integration. So that's given to you in the question, this fella here. So anyway, let's start off and see how we're going with this one. Now, you've got to find the velocity in terms of t, which means I've got to change this acceleration to either dv dt or v dv dx or v dv ds. I'm saying v dv dx this time because these are in terms of that. So I'm going to change this to dv dt. dv dt is equal to 25 minus 10v. I'll separate the variables. dv over 25 minus 10v is equal to dt. I'll integrate both sides. Now this is like nothing we've seen before, so if that happens, you go to the log tables and you find a relevant substitution in the log tables. Now, in the question, this was given to us here, so you can see that if I compare these things here, that they are very similar. The A is 10, and the B is minus. The A is 25, and the B is minus 10. So those are the two things I'm going to be having a look at. Right, so comparing everything here to this one, when I integrate this, it's going to become 1 over B, which is 1 over minus 10, by the ln of A, which is 25, plus bx, which in this case is minus 10, and the x, of course, in this case is v. So look how, see, this now represents this. Plus c, your constant of integration, and that is going to be the right-hand side. When I integrate the right-hand side, that just becomes t. So let's find the constant of integration. So my initial conditions are, of course, that the particle starts from rest. So the v is 0 at time 0. So if I put those in here, look what happens. I get minus 1/10, the ln of 25 plus minus 10 times v, which of course is 0, plus c, and that's going to be equal to 0 because times 0. Which means that c is equal to, if I rearrange this, 1/10 the ln of 25. So now I'm going to put this c back in here into this equation here, and it becomes minus 1/10 the ln of 25 minus 10v plus c, which is plus 1/10 the ln of 25, and that's equal to t. So I've linked those two equations here now. Now you can see that these are ln's, they're subtracted from each other. So remember, when you subtract ln's, you can divide them. So I'll take out that 1/10 because it's common to both, and I'll have the ln of 25 minus the ln of 25 minus 10v, that's equal to t. So I can write this as 1/10 the ln of 25 over 25 minus 10v. So that's equal to t. Okay, so that's fair enough. The only thing is, it says to me find v. The question says find v. So if find v means I have to get my answer in terms of v. Can't leave it like this. So first of all, I'll get rid of that 1/10. So this is the ln of 25 over 25 minus 10v is equal to 10t. I'll get rid of the ln on the left-hand side by eing both sides. So when I e to the ln of 25 over 25 minus 10v is equal to e to the 10t, that e and ln, of course, will cancel. So this will become 25 over 25 minus 10v is equal to e to the 10t. Cross multiply, 25 is equal to e to the 10t by 25 minus 10v. So I'll bring over that e to the 10t, and that's equal to 25 minus 10v. Okay, so this will become 25 by e to the minus 10t minus 25 is equal to minus 10v. So what I think I'll do is divide all the way across by 10 and change the signs all the way across. So this will become this will become, well, I'll just rewrite this first of all. This will be 25 minus 25 e to the minus 10t is equal to 10v. That's when I change all the way across. So that means my v is equal to 2.5 minus 2.5 by e to the minus 10t.